Hey and welcome to another tutorial. Today I will show you how to create those cool looking Guilloché parents, which is just a fancy name for those like kind of certificate borders or anything else which is kind of security related. You can see the different parents or banknotes or whatever. So today we will try to do this inside Microsoft Word using Visual Basic for applications, that is macros. And I will start with a blank document, but I will actually not start inside Word, but inside this Desmos web page when I can graph any function, which will be very useful for the beginning. So what we will start with is a sine function, and I hope you know how the sine function looks like. It's a very common function. What I can do is I can multiply this x by a certain value. I'll multiply it by parameter a, and I will add the slider. And as you can see, if I change the parameter a, I'm just stretching this function. I'm changing this horizontal spacing. The other thing I can do is I can add something. I can add another value, let's say a parameter b, and again I will add the slider for the b. And what the b is doing is the b is moving this function around the x-axis. So what I can do is I can add a new function which will be sine x times a plus something, plus some hard-coded value, and it will be 0 for this one. And I can duplicate this function. I can change it to +1, I can change it to +2, and I guess you can start seeing some kind of pattern emerging from those multiple functions. So this will be +3, I will do it +4, +5, and by the time I get to +6, you will see that the +6 almost look like as it's on the very same spot, on the similar spot. That's because the one loop of the sine function is 2 pi, so 3.14 times 2, which is 6 point whatever. We don't have to care about the exact values right now in here. We will care about those inside Word, but just for now, you can see that by stacking multiple functions being moved by the x-axis creates this nice looking pattern. I can still change the parameter a to get a different looking pattern, different kind of spacing. I can get it very tight or much broader. And I think that this should be enough for us to start actually drawing something inside Microsoft Word. So all we have to do is to remember that we want to have a function sine x times some parameter plus some hard-coded value. So I will jump to Word and I will open the developer ribbon. In case you don't see it, you have to just right click and select customize the ribbon and make sure that the developer checkbox is being checked. Inside the macros for this document, I will create a new macro which I will call draw Guilloché. I'm not quite sure if I can spell this right. Hopefully I did. I will resize this window a little bit, and what I need is an array of points which will hold all the points. So I will define a new array called array points, and it will go from 1 to some certain value. Let's say that value will be some constant, so number of points, and I will define this constant number of points to be some very high number like 512. And for the second parameter, it will go from 1 to 2, which is for x and y, and it will be as single. That has to be as single for Word in order to work. As the last step, and I'm jumping around, but as the last step, I want to draw this shape. So active document dot shapes it's called add polyline, and the add polyline requires this array. So I will use this array points, and I will say select. Now if I run this, it will do nothing because those array points are not initialized, and I'm pretty sure they are 0 for now. So what I need to do is I need a new loop. So I will say for counter going from 0, or maybe from 1 to number of points. I will set those points, and I will say next counter. So I will set those points to the arrow points counter, which is the first one, and the second one is 1 for x is some value, and for the x value I want to just move from left to right. So I will use the counter. I may multiply it or divide it by some value, but I will just use it counter for now. Since we have 512 points, it should pretty much cover most of the page for now. The interesting thing is for the second parameter, which is index of 2, which is for y. And for y, I of course want the sine function. So sine function, which will be of the counter, which is the x for now, times something, times, let's say, for example, I don't know, 0.2. And I want to, of course, add something to it. So I want to add something to it, you know, 0, for example, for now. And I will see if that works. If I run this, I'm getting something very little or very tiny. You can see that there is a sine function in here, but it only goes between -1 and 1. So what I want to do is I want to multiply this by some value. So I want to multiply it, for example, by, I don't know, by 20. And I will probably also move it more to the bottom, so I'll add some value to it. So if I run this one more time, you can see I have this nice looking sine function. And what I can do is I can, you know, start running this macro over and over. So I will run this one more time with being this parameter 1, you know, being this parameter 2, and I'm getting very same results as I was getting in the Desmos website. But of course, this is not what I want to do manually. So what I can do is I can create another loop which will cover everything in there. So I will say for counter shapes, for example, going from 1 to number of shapes, which will also be a constant. Number of shapes, for example, I don't know, 5 for now. I want to do everything this, and in the end I want to say next counter shapes. Of course, I have to add a different value each time, so I will add a new value and I will probably calculate this value even before I jump into the loop. So I will set that the x increment, let's call it this increment, equals to 2 pi, so 2 times 3 point, you know, 141 whatever, divided of course by the number of shapes. So divided by the number of shapes. So this should be increment for each individual shape. So I will add this increment times the counter shapes. And the counter shapes start from 1. I want this probably to start from 0, so I will just you know, make it one small. Okay, hopefully that should work. So if I run this, I'm getting 5 different shapes being offsetted in a way that it's looping nicely. And you can tell it's 5 different shapes if you take a closer look at the end of the shape, where you can count that we also really have 5 different shapes in here. So this should be like the first kind of pattern. You can experiment with different values. You can experiment with, you know, changing this first value that will change the horizontal spacing. You know, it will make it wider or more dense. You can of course experiment with the number of shapes in between, so you can increase it by to 10, for example. You will have a lot of different shapes and very, you know, subtle pattern, whatever. But what we want to do is we want to make it more interesting. And we can do it more interesting by several different ways. One way how to make it more interesting is to make sure that not only the sine function goes up and down like this forever, but after a certain time it changes the size. And we can do it in a way that we introduce a new sine function in there. So what we can do is we can have another sine function, and this sine function will have much broader, you know, pattern. So x times, for example, 0.1 or 0.5. So I want this original sine function to be modulated by this very wide sine function. So what I can do is I can just, you know, multiply it. I can multiply it, and what I'm getting is this first function being modulated by the second sine function. So if I change the parameter a to make it more dense, so you can see it's somehow being, you know, modulated by the second function. So that's exactly what we will do in here. And what I'm thinking is, instead of just, you know, writing a very long line in here, I will probably split this into multiple lines. So I will say that this is the okay. So this is the like the first main sine function. Let's call this main sine function. And I will not move it. I will move it down here. So I will, the last step will be to move it to the bottom. move it to bottom, and in between what I will do is I will introduce a new sine function. So this will be like the big wave. This will be big wave. And what I want to do is I want to multiply this original sine function by a new sine function. So new sine function of the counter times some very small value, I don't know, maybe 0.05. I guess we can always tweak it later. So 0.05 it is for now. If I try to run this macro, you will see that we already have a nice looking pattern. It's kind of the original sine function is being modulated by another sine function, and I kind of like this shape. I can still increase the number of shapes if I feel that the 5 is too small, like maybe 8 would look better. Okay, kind of like this a lot. Maybe what I can do is I can try to make it like aligned to the side, so it's not going to both sides, it's only going to one side, so I can actually use it as a border. And I guess I can do it by just squaring this. So I can do it by just squaring it to or raising it to power of 2. So if I just raise it to power of 2 squared, I should get something. It will most likely not be what I'm looking for, and the reason for this is that we already have multiplied the first function by 20. So 20 times 20 is of course 400. It's getting to some very high values, but I really will only want like a small edge, so I want this to be much smaller. So what I can do is, instead of multiplying this by 20, I can remove this from here, and I can actually multiply it by 20 after it's being squared. So I will multiply it by 20, and I will call this make bigger, or even make visible, because it will be visible. And if I run this again, I'm getting a nice looking border, exactly how I want it to be. So I'm getting, it's getting only two positive values, going from 0, and it kind of resembles those Guilloché patterns which you usually see around certificates. The last step which I can do is I wanted to say randomly, but somewhere introduce some new values. So for example, when I was modifying this original sine wave by a new sine wave, what I can do is, for the new sine wave, I can actually make this a little bit different. So I can add some value to it. So for example 0.2, I can move it more to the top. So if I use this, which is moved to the top, if I use this to multiply it by this, and I have of course make this into brackets, and then I square everything. I can probably resize it to see it better. Okay, and then I will square everything. What I will get is, based on this offset of the second function, I will get a shape where every second hill, or how to call it, is smaller or bigger. So I can try to do this here as well. For this second sine function, I will just add some value to it. So for example 0.1, and if I put this inside the brackets, I should get the very same looking shape where each second repetition is a little bit smaller, or each second is a little bit bigger. And I guess I will stop here. I will leave something for the next tutorial, but hopefully you should already have a good feeling of how to create such patterns for anything you want to make. And that's it. This one more time, this is the original tutorial or original document. Since we have kind of separated each step into into individual lines, what I can do is I can randomly comment out some of those. So I can, for example, leave out this big wave and making it squared. If I just comment this section, we will get back to this original pattern, or I can only make it or modulate it by the second sine wave, but not making it squared, so it goes to both sides. And you can see, since I have this second parameter for this big wave, I'm still oscillating between small and big shapes. So I can maybe make this a little bit bigger so you can see it better, that we are alternating between big and small shapes. Maybe one more thing I can do before I finish this tutorial is I can make sure that once everything is being drawn, I want this to be grouped inside one group. So for the selection I will say false, which will not replace the selection. So it will actually add this to the selection, and as the last step I will say selection.shapeRange.group, which will group all the selected, all the drawn objects. So if I run this again, now everything is being grouped inside one group. If I select the home selection pane, you can see that everything is inside one group, so it's much easier to work with those shapes being inside one group. And that's it. Thanks for watching.